and the web as we know it, I feel fine.
LOD2, Creating Knowledge Out of Interlinked Data. Welcome to the LOD2 webinar series, Linked Open Data Tools and Services for Publishers, Enterprises and Governmental Institutions. LOD2 is a large-scale integrating project co-funded by the European Commission within the FP7 Information and Communication Technologies Work Programme. This 4-year project comprises leading linked open data technology researchers, companies and service providers. Coming from across 12 countries, the partners are coordinated by the Agile Knowledge Engineering and Semantic Web Research Group at the University of Leipzig, Germany. LOD2 will integrate and syndicate linked data with existing large-scale applications. The project shows the benefits in the scenarios of media and publishing, corporate data intranets, and e-government. Once per month, the LOD2 webinar series offer a free webinar about tools and services along the linked open data lifecycle. Stay with us and learn more about acquisition, editing, composing, connected applications, and finally, publishing linked open data.
So, hi everybody. So my name is Renaud Delbrouille. I'm the CTO of Initiotech, and today with Arish Kumar, we will present you SIREn and the plugin for Elasticsearch and how to use SIREn with Elasticsearch. So just a bit of a background. SIREn is originating from the LOD2 research project. So at a certain point in time, it was one of the output of this project, and since 1 year, now Initiotech, a private company, is trying to commercialize it. So the agenda for today will be, so we will just give you an overview a bit on the nested data model and on SIREn, and then we will dive a bit into how to start with the SIREn Elasticsearch plugin. And then later, Arish will provide you a live demo on how to use SIREn with Elasticsearch to index and query the Crunch-based dataset. So let's start. So about the schemaless nested data model. So this nested data model is becoming more and more prevalent nowadays. With a huge amount of information we need to deal with. And this here cover model like JSON, XML, Avro that are kind of hierarchical in nature. So where one record can be nested in another one arbitrary in an arbitrary fashion. So also, a particularity of this model is that usually there is no strict schema and structure enforced. The tree, the nested model can be arbitrarily large and can change across record. This bring the problem of how to use this data. So there is already some tool, certain database like Apache Drill that try to handle this kind of data. There is support in big data domain with Hadoop and all this matter. But here what we were trying to solve is how to search efficiently this data and search and analyze this data. And in a schemaless also fashion. So we didn't want to spend or to invest significant design effort upfront before being able to search a certain data set here. And you can see that by supporting fully schemaless data, it brings a certain flexibility and ease of development in the product or application development. So this was the main goal of SIREn, to try to handle this rich data model. So we created SIREn as a plugin for Lucene, Solr, and Elasticsearch. So you just have to, if you have Lucene, Solr, and Elasticsearch, you just have to plug to drop our jar, and you will see that SIREn offer you a new way to index data, a new way to query data. So usually, Lucene, Solr, and Elasticsearch was developed for kind of a more textual document or flat model where you have a list of key value pair, but not really for rich data model, hierarchical data model like JSON with arbitrary nested object, nested array, and so on. So SIREn supports this full model of JSON with nested object, nested array, data type. But also, one point is that SIREn, even at the moment, if the API support only JSON, underneath, the architecture and the model is compatible with various other nested data models. So for example, here you can think of JSON LD, XML, Avro, and so on. So one particularity of SIREn is that it's schema agnostic. So in fact, SIREn doesn't require any schema definition to index and search the data. So you can just push arbitrary JSON document directly into SIREn and start to search it right away. And yeah, if you have some schema definition, for sure, you can then input them into SIREn, and SIREn will use them. Then also one particularity is that you will see during the demo that the schema definition can change across records. So for example, you can have in a record certain properties, it is a string, and in the next record, this same property or same path become a nested object or array of not a string but of integer, etc. Usually Elasticsearch have some problem with that, and we will show you that SIREn, this doesn't cause any problem with SIREn. And the last point is that SIREn, we developed SIREn and designed SIREn from the ground up for high performance and scalability, especially to support this hierarchical data indexing and querying. So just here to summarize the key feature of SIREn, so it supports flexible schema, so you can search and analyze data without any upfront modeling effort or ETL beforehand. It supports nested data model, so you can search and analyze arbitrary nested data at scale and with low latency. And it's also plug and play, so you can use SIREn to search this nested data using your Solr and Elasticsearch installation. And it will be completely integrated with the API of Solr and Elasticsearch. So now a bit of overview of Elasticsearch here. So for some of you that might not know this system, so Elasticsearch is the document-oriented search and analytic engine. Is also API and default model is JSON document, and is based on Apache Lucene. But you will see maybe more in the demo of Arish that while it supports the JSON document model, it doesn't support really fully the nested data querying due to its type of indexing modeling. So it supports also distributed replication and have a fully REST API. So just here we introduce some basic concepts that we will use during the rest of this presentation. That is important in Elasticsearch. So in Elasticsearch, an index, you can see it as a collection of documents or like a database in a relational data model. And an index can have multiple shards and a replica. Inside each index, you can have a type. A type is a set of documents sharing the same schema, so it's similar to a DB table. And a document here is equal to a JSON object, and which is uniquely identified, and is similar to a database record. In SIREn also, another thing is that we see a JSON object, so a document as a tree model. And there is different mapping available, so you can imagine that there is different way to map a JSON data model, JSON object to a tree, and we provide different mapping, with each one providing more or less flexibility or more or less performance. And also inside this tree, you have a tree is composed of nodes, and the particularity of a node in this tree is that it can have a parent and one or more children, and can contain data, either text, numeric, Boolean, or other type of data. So just to show you a bit here, so on your left here, you have a JSON object, which is kind of taking out from the Crunchbase dataset, so which describes the Elasticsearch company. And on your left, you will see how we construct the tree how we map this JSON to a tree model in SIREn. So first here, a tree start with the root, which is the blank node that you see. Then you can see that we create a node with name Elasticsearch to encode this attribute. Then another one with category search. And then we introduce another node, founding grant, which will be a parent of multiple child node, and so on. And so you can see here the founding grant node have 3 children, code A, raised amount, and funded year. And the fourth one, which is investment, which also is another nested object with two other attribute value pair. And it can continue like this indefinitely. So now, just so we saw a bit the concept behind SIREn and Elasticsearch. So normally, here is still not yet out the Elasticsearch distribution, so it will be coming soon in the next days. But when it will be ready, you will just have to go to this webpage, sirendb.com/download, and click on the Elasticsearch distribution 1.3 button to download our distribution. So this distribution is pre-configured with SIREn and pre-installed with SIREn. And here, I just show you, this is what is inside this distribution archive. So the first directory contains the dist contains the SIREn library. You have also the SIREn Java doc, and then you have the example directory which contains the Elasticsearch distribution. So if we zoom inside this directory, you have the executable in the bin directory where you can start Elasticsearch. You have the configuration of Elasticsearch in the config directory. And then inside the plugin directory, you have the SIREn plugin pre-installed. And then in the dataset directory is just some data that you can run and use to run the demo provided with the distribution. So now to start Elasticsearch, you just have one time you downloaded the distribution, extracted. You just have to go to the example directory and run the bin/Elasticsearch. And just to check if it works, normally you should see that I have loaded the SIREn plugin, and then it has started without any error. At this stage, it means that Elasticsearch is running with SIREn loaded. So now we will show you the first thing is how to configure Elasticsearch, an index in Elasticsearch to index data with SIREn. So the main thing to do is to create mapping, to register a mapping. For here we will register a mapping for here's the test index and the company's type. And we will create a SIREn field. So it should always be called _SIREn_source, which is a kind of internal, which will be an internal field that will be used by Elasticsearch by our plugin. And it is configured with the analyzer, which we call hybrid JSON. So like I told you, there is different mapping of the JSON model to the tree model. Here the hybrid JSON is one type of mapping, and we have other one, but here we will focus on this one. And here also we register the posting format. So in low level, this is the file system that SIREn will use to index the data. And that will be registered in Elasticsearch and in Lucene. So one time you have registered this mapping, you can start to index a document using this command. So we will index the first document in the index test and in the type. Company, and with the identifier 1. And this is a document we showed you previously about Elasticsearch. Next, I will explain you, during indexing, how to customize data type and to customize the analysis of the different data type in the JSON document. So by default, SIREn distinguish between 5 types of value in the JSON model. So there is first the field, which represents a field of an object. Then there is a string and a long here, and here a string, and you have also double and a boolean, which are not shown here. And each one can have by default pre-configured analysis but you can configure them at will. Yeah. And I will show you how to do this. So normally, to change the analysis of this data type, you need to go to the configuration of Elasticsearch. So in config elasticsearch.yml, and enter these different settings. So prefix with SIREn.analysis.datatype. So the first one here, you can see that we reference the data type http json.org/field. This is the identifier of the data type, unique identifier that is known by SIREn. And here we will define an index analyzer of type keyword for the JSON field data type. Then you can also not only configure index analyzer, but also a search analyzer that will be used during search time. So here we use just a simple analyzer at indexing time for the data type string, and a simple folding that we will create below. So you can create a custom analyzer in Elasticsearch, so using the index.analysis.analyzer setting, and make a reference to it inside the SIREn setting. You see here, we just use the reference. And here, you can configure long. So about long, for the long and the double, SIREn provide two type of analyzer that is specific for this numeric value, and that is mainly used for efficient range query. And they just name long and double. So for example, for the data type long, you just have to put index analyzer long. So now that we have indexed a document, we can start to look at the searching this document. So here I will present you the main three operators. So there is much more, but the main three operators of SIREn. The first one is what we call not query. So a not query is a query operator that will try to match a Boolean text expression within a node of the tree. So you can see here, inside this comment, we define hybrid JSON, which defines the type of query type, the SIREn query type that we want to use. And that will be an indication for Elasticsearch to be able to know how to parse the next query. So here, this is the SIREn query, the SIREn node query. And he is trying to search, just a keyword search inside the node. So on your left, on your right, you can see that this node search, in fact, which can be a full text query, either a Boolean, a phrase, a range, a fuzzy, regex, and proximity. We support all this in SIREn. And this node query will match the node category code and the search. So the node query can be also extended with a specific settings, which is attribute. So it's to define in which attribute this keyword should match. And because you see in each node of the tree, we are encoding the attribute and the value. So here, if we want to restrict the search to only the node with an attribute category code, we use a query search and attribute field with a category code value, and it will match only this specific node. So now the next Twig query. So the Twig query is a core operator to create a tree structure or query and structure query. So this operator encode, in fact, and provide a way to search ancestor, descendant, and parent-child relationship between the node of the tree. So usually, a Twig query consists of the root query. Here it can be a Boolean query, and with one or more child. So here we have one child, which will be a phrase query, and one or more descendant. The descendant is a node that does not occur directly one level below, but can occur 2 or 3 or 4 levels below. And this descendant query in this example is a Boolean query. And this also, this tree can be arbitrary nested to form complex tree structures. So here, for example, we are nesting another Twig query as a child of the first one. And one particularity is that you can see that each element of this Twig query is each child, and each descendant can have a unary Boolean operator applied to it. So you can see that the phrase must appear, the child phrase must appear, but the Twig child must not appear, and the Boolean descendant should appear. So this allows you to have quite some flexibility in the way you are creating a query. So just to show you an example, so here is a command here to execute a Twig query. So here we define the Twig query operator. And first, the Twig operator require a root, even if the root can be optional. You will see in the demo of Arish. Here, the root should match a node with which contain founding ground. And the next is the child clause. Here we have a clause for a child, which is a node query, which should match the query the founded year 2012. And you can see that here, if we execute this query, first he will try to match the root, so he will find the node founding ground, and he will check in his set of child if he found a node that match founded year 2012. And in this case, he found a link, and therefore, this document is a match for this particular query. So this was a Twig query, and also we provide the SIREn have the particularity to support a proximity query not only on text but also between the node of a tree. So in the tree, each node is ordered, and you can see on your right here, for example, the first node name Elasticsearch is as the order 1, category code as the number 2, founding ground as the number 3, and the second founding ground as the number 4. Yeah. And based on this information, you can create a proximity query. So, for example, here we are asking all the documents where we should have a founding ground matching data collective next to the founding ground, another founding ground with matching index and venture. And this Boolean proximity operator contains two attributes. The first one is in order. Here we put the order constraint. So these two Twig queries should occur next one after the other. And the slope, this is the second parameter, defines the proximity constraint. And a slope is how many positions are allowed between each of the nodes. Here we say that the slope is 0, so in fact they need to occur next to each other. So if we go over this query, so here are the two Boolean clause here. If we go over this query, the first Twig here match the founding ground and the descendant node name data collective. The second clause match founding ground names index venture, and we can see that SIREn can see that these two nodes are in order and have a slope of 0, so we can see that this document is a match. So we went over the basic of the Elasticsearch SIREn plugin and how SIREn can be used with Elasticsearch. Now, Arish will show you a live demo on the Crunch-based dataset here.
And you should be able to hear me as well. So Reno took you through, how the internals work, and what we want to do is to take you through how you can quickly get started with using Elasticsearch and SIREn and start loading data and querying the data. So to get started, it's very simple. We will be putting up the distribution, the SIREn distribution up very soon. And what you need to do is to download that distribution. Just unzip it. I can take you through it quickly. And run Elasticsearch. So if you see the command on the top, bin.elasticsearch, if you run the command, Elasticsearch starts up. The plugins will be automatically loaded, and you can start playing with the application. So I've already started Elasticsearch. So Elasticsearch also comes with a nice UI. It's called Marvel, and they give you a console called Sense. And that is what we're going to be using for this demo. So what you can do is you can go to this port 9200, and you will be able to start using this application here. So as just to recap, as Reno said, when it comes to Elasticsearch, we have an index, we have types, and we have documents. So index corresponds to a database, types correspond to tables, and documents correspond to records in a relational database. So the first thing, so let's just quickly go through how we can set up a simple index, load some data, and do some basic querying. So the first thing that you need to do is to create the index. So in this case, let's just call it companies. So we have created an index called companies. And then the next thing that we need to do is set up a mapping. So I've described the mapping here. What the mapping does basically is, in this particular case, we are trying to say that index it both in Elasticsearch and in SIREn. So whenever you add a document now, two indexes, parallel indexes are created, so that you have the power of Elasticsearch as well as SIREn. So we create the mapping, we execute this command. So these are all are driven by a REST interface. So we are just using the REST interface to post these commands. Then what we're going to do is to index two simple documents. So there are two companies here, and we have two simple fields, name and description, and we can add them to the index. So we add the first document, and we add the second document. And here you will see how you can query the data. So the first query is actually an Elasticsearch query. So here you have query, match, description. So the syntax is a bit verbose, but it's actually very simple once you get familiar with it. So you have a match query here, and this is the field name, and this is the keyword that you want to search against, and you get this one result which has social in it. Now the other thing is you can also query using SIREn, because we maintain a parallel index, and as Reno was describing, SIREn has its own query syntax, and what you're trying to query here is for a specific node, which has attribute description and which has the word social in it. So it is essentially it's exactly the same query, but using SIREn. So if you query using SIREn, you see the result as well. This is just to show you how to get started. So just to recap, you create an index, set up the mapping to ensure that the data is indexed in SIREn as well. You add your documents, then you start querying it, and you can query simultaneously with Elasticsearch as well as with SIREn. Now let's just clean this up before we proceed. Let's just delete this index. Now, how does SIREn enhance Elasticsearch? I mean, that is the whole objective of this demo, and we will break this demo up into three parts. First, we'll look at what Reno was speaking about, schemaless indexing. So what do we mean by schemaless? How is it helpful, and so on and so forth. The second thing is we will talk about how we index arrays of nested objects. So this is a core capability which is extremely important to index one-to-many relationships very efficiently. We'll look at that. And finally, we'll look at how SIREn and Elasticsearch complement each other, where SIREn, you can use SIREn's query capabilities alongside Elasticsearch's other capabilities like faceting and so on and so forth. So let's get started with this schemaless indexing. What does it mean? How is it useful? And so on. So again, let's just create a fresh index. Let's set up the mapping so that we index it in SIREn as well. Now let's take a look at the same two documents, but it has two additional fields. If you notice here, you have the location field, which has an object, which has attributes like city and state. But in the next document, you have a string attached location. So this is classic heterogeneous data, and this use case occurs all the time when you're trying to integrate data from multiple data sources. The fidelity with which you describe data is different in different data sources, and this is a situation that you'll constantly run into. So if you just straight away try to start indexing it, so let's just index the first one. So Elasticsearch indexes it without any problem. But the next time when you try to index the next document, Elasticsearch throws an error. It basically says, hey, it was an object in the first document, but here it seems to be a string, and I can't index it. But SIREn actually doesn't have a problem with dealing with data like this. But what you first need to do is to first turn off the indexing in Elasticsearch. So what we say is we can put in a location and basically say tell Elasticsearch not to index it. We say enabled, and we say false. So now what happens is that we are told Elasticsearch, for companies, don't index location, and SIREn will take care of it. So we will just have to delete the index again and create it afresh. And these are the kind of problems that you will not have if you index data only in SIREn. So we create the mapping afresh, and now we index both these documents again. And you notice that there was no problem now in indexing both. But we should remember that these documents, the location field in particular, has not been indexed by Elasticsearch. So if you query for New York, location New York in Elasticsearch, you'll not get any results. But when you query the same for SIREn at the SIREn index, you'll get the correct match, which in this case is adaptive blue. But remember that here we're querying the field with a string. You can also query the field with an object associated with it. And to do that, we need to use the Twig query, which is what Reno was describing earlier. The Twig query describes the relationship between parent and child nodes. So in this case, the parent node is location, and the child node is city San Francisco. And this is the syntax. You say Twig, you specify the parent by using the keyword root, and then you specify the child nodes under the child key here. So this is how you write the query, and when you issue the other this, you get the other result essentially. But you can interestingly, you can even SIREn supports wildcards. So for instance, if you do not know what is the keyword at the parent level, and this can happen when you are again combining data from multiple sources, where you might call it maybe address in one document and location in the other, but the city field is still the same. You can just leave it out, use wildcards, query it, and you'll get the same result. This is again something that you will not get with Elasticsearch. Now, finally, just to wrap it up, you can also give a Boolean to query both when the case when a location is associated with a string as well as an object. So what you do is you set up a Boolean clause. You use the Boolean keyword, and then you set up both. You set up a Twig query, and you set up a node query, and you do a Boolean on both. That you're basically saying these are unary operators. You're basically saying either the Twig should be present or the node should be present. And when you issue this query, you'll see that both of them match. But here you have said San Francisco, and here they're New York. They're in different cities, and you get both these matches. So what you're seeing is, and this is just one of the ways which SIREn supports schema-less search. There are other aspects about schema-less. For instance, heterogeneous arrays of data, where you can mix strings and numbers in the same array, and Elasticsearch will not be able to do that, whereas SIREn has no problem. And this functionality is extremely useful when you're dealing with data that has been integrated from multiple data sources. So that was a quick introduction to schema-less indexing. So let's move on. The next interesting capability that SIREn offers is indexing of arrays of nested objects. So what do we mean by that? Let's just take a look at the same two companies again. And if you look at fundings, you will see multiple objects nested under funding, so multiple funding rounds effectively for this company. So you have round A funding by one investor, you have round B funding by another investor, and so on and so forth. Now, you run into an interesting issue if you just use Elasticsearch's default way of indexing this data. And let me just take you through it very quickly. So again, we create the index, we set up the mapping, and then we add these two documents. The first document about radar networks, and the second document about this company, Adaptive Blue. And notice that in the first company, Sequoia was involved in the B round funding, whereas in the second document of the company, Sequoia is involved A round funding. So say that we want to give a query saying, give me all the companies where Sequoia has participated in an A round investment or A round funding. So this is how you would formulate the query in Elasticsearch. But if you issue this query, something interesting happens, which is you end up with getting both the results. But that is not actually accurate in the sense that there's only one company out here which has received A round funding from Sequoia, which is the second one, Adaptive Blue. But you get both. And the reason why this happens is that by default, Elasticsearch flattens the fields, and it cannot distinguish between different nested objects. But SIREn, on the other hand, has no problem. So if you formulate the same query in SIREn, so what you have done here is you have created a Twig object and you have created two child objects, which essentially should be present in the same nested object. That's what you're describing here. So I've left out the specifying what parent it is, because we can use wildcards. Then I have said I need a node with round A, and I need a node with with investor Sequoia under the same nested object. And if I issue this query, you'll get the correct result, which is this particular company where Sequoia has been involved in A round funding. So this is something that incidentally can be done in Elasticsearch. They are put together a mechanism where you can do what we call nested object search, but it's extremely inefficient. In fact, we have done benchmark tests against their approach versus our approach. We have a detailed benchmark analysis of the stuff, and what we have done here is essentially a conjunction against nested objects. And if you look at that for conjunction paragraph, you see a significant boost that you get from SIREn. It's almost like 2 to 3 times faster. You can see it here. So this is one of the core capabilities that or benefits that you get from using SIREn. So if you're indexing one-to-many relationships, you can get performance which is 2 to 3 times faster, while also using very little memory, which is another benefit. Finally, one of the things that I wanted to take you through when it comes to nested objects was the proximity thing, which Rena was referring to. So let's look at what proximity means in this case. So we're looking for objects that the order of objects here, in the sense that, so for instance, we have a B round funding from Sequoia followed by a C round funding from Kleiner. So I want to know what are all the companies where Kleiner has followed Sequoia immediately. So Sequoia has done a funding round, and Kleiner has followed up with a subsequent funding round. So in the first one, Kleiner follows Sequoia immediately, whereas in the second one, Kleiner follows Sequoia after an intermediate round of funding. So if I want to just query for companies where Kleiner has immediately followed Sequoia, you can use proximity queries. So here is the proximity query. Again, we set up a Boolean query. We have these two twigs, which captures the relationship between funding and investor Sequoia, and funding and investor Kleiner. And here we specify the slop as 0, which basically means that I want them to appear adjacent to each other. So when I issue this query, I get this one result, which is a Sequoia following Kleiner. But if you change the slop to 1, you'll get, just give me a sec. You'll get both the results. So what you see here, for instance, is Sequoia following Kleiner, but with one intermediate investment. So the slop is 1, and here the slop is 0. So 1 or less, both match. And this is again very valuable in various contexts. This is, for instance, if you have resumes, for instance, if you have positions of people and you want to know who has gone from Google to Facebook. And so if those positions appear one next to each other, and this is the kind of query that can catch it. Again, this is unique to SIREn, and it is not offered by Elasticsearch. So to wrap up quickly, the final thing that I want to run you through is how you can use the functionalities of Elasticsearch alongside SIREn. So one of the big things that Elasticsearch gives you is this nice idea of rivers, which are essentially data plugins, where you can plug in Elasticsearch to take in data from data sources like file system, like databases like MongoDB, and so on and so forth. And they call it rivers, basically. So now this is something that we can reuse with SIREn. So I think I need to switch it here. We have already loaded the data in this case for the demo. So we have gone through the same process. We have created the index. We have set up a mapping. Notice that the mapping is very elaborate. This is again to deal with heterogeneous data. What we have done is we have tried to turn off various fields which have heterogeneous data so that Elasticsearch doesn't have a problem. And to set up the import itself, so we have a folder here with several thousand companies, and we said to take all of this data there and add them into this index called company-solve, which you have already created. So when you query this this index, you'll see there are 17,000 companies. And these are all data taken from the Crunchbase dataset. Crunchbase is a big database of technology companies mostly, and it has very rich and valuable information that you could make use of. So this is a traditional Elasticsearch query, and here is a SIREn query. So what you want to do is you want to query for all companies with mobile in the description, and you get about 600 companies from that data set. Now, what gets interesting is that, say you want to extract a specific field, say the category field that you see here. So you can use SIREn to do that, but more interestingly, you can use Elasticsearch to extract the specific fields. So for instance, if I give this query after specifying fields, I get the list of companies, but with the category code field as part of the response. So that is one, the projection aspect of it. The second thing is sorting. Again, SIREn doesn't currently support sorting, but you can use Elasticsearch's sorting mechanism. So you specify the sort on the specific field here as another clause in the query. You give a search, and now you can see that the companies have been sorted. You have some special character here, but you have 10 jumps. You have 648 group, whatever. And so on and so forth. So you get sorting. You can use sorting from Elasticsearch. And maybe the most interesting feature is that Elasticsearch offers is faceting, a very powerful feature. And what we want to do is to facet on categories. So it's very simple. You say facets. You give a name to the facets, and you specify the type of facet, which is the terms facet in this case, and you specify the field on which you want to facet, which is category code in our case. So you run this query, and you have the results, but if you scroll down, you'll see the facets. So out of the 600 companies, 327 of them are mobile, 89 are software, and so on and so forth. So what we're trying to illustrate is that you get the rich query capability of SIREn, but it is complemented by all the rich functionality that Elasticsearch offers. So you get the best of both worlds. So that's essentially it.
Okay, so yeah, we can jump to the conclusions after the demo of Arish. So just to wrap up and to summarize, yes, the key feature of SIREn, we have shown that you have a kind of a dynamic and schemaless data management. You fully support nested data model, indexing and search over nested data model. It has been designed for high performance and scalability. It provides a powerful search operator like the Twig and the proximity operator. And yeah, it's well integrated into Solr and Elasticsearch. Yeah. Like you see during the demo of Arish, you are able to leverage all the functionality of Elasticsearch alongside SIREn querying. And so yeah, you can go to our website, sirendb.com, where you can download the previous version. The new version with Elasticsearch distribution will come in the next day, like I said previously. You have also access to blog post and to this blog post about the benchmark that Arish mentioned. If you are more interested about technical detail and performance compared to block joint, which is the way Elasticsearch is managing nested objects. And you can contact us at Indiciatech, info@indiciatech.com. Yeah.
The one additional thing I wanted to mention was that SIREn is available both for Elasticsearch and Solr. So if you're a Solr user and you want to continue using Solr, you can get all of the functionality that SIREn offers for Solr as well. So it's compatible with both these platforms. So, Thomas?
I think we can go to the question now.
Yeah, thanks for this good presentation. And there are already some questions which come in via the question tab in the control table from the GoToMeeting software. So one is, I'd be interested to know whether there is JSON LD support in SIREn.
Yeah, fully support. So the thing is that JSON LD support. So there is a particular operator introduced by JSON LD. The thing is that by default, yes, SIREn support fully JSON. So yeah, you can push JSON LD data and index and query it. After, if you want support for specific operator like for data type and so on, yeah, at a certain point, I think we will introduce them. After a full support of JSON LD, I think in certain cases will not make full sense in SIREn world, but
sure. No, but we also want to emphasize that we already have a significant amount of support for the conceptual paradigm of JSON LD. For instance, we have support for namespaces out of the box, and this is something that's very useful and very tricky if you use Solr or Elasticsearch out of the box. We give support for namespaces, for instance. Along with that, we also are Schema-Less, which is very relevant for the linked data world, and this will also be very useful.
So usually in our daily business, we are already playing with JSON LD and extracting from a Sparkle endpoint data, transforming into JSON LD and pushing it to SIREn for search. So just to let you know that it's possible already.
So we have a bridge between Sparkle endpoint and SIREn already, which we have implemented for a customer.
Okay, thank you. There was also a question about the schemaless thing of SIREn, because Renaud, you have mentioned that there is sharing the same schema in your slide somewhere. Is there? How is this solved with the schema-less? Can you make a clarification somewhere? I think it was in the first slides.
Okay. So can you repeat the question, Thomas?
Sharing this same schema, you have mentioned this somewhere in your slides, and the user asked, I thought it was a schema-less. Please clarify.
Share the schema. You mean maybe, I imagine maybe here a type of document sharing the same schema. I mean, here is the schema of Elasticsearch. So for sure, yes, SIREn doesn't have a schema, but Elasticsearch underneath have a schema. So the basic schema that you can have is an ID field and a JSON SIREn field. This will be the basic schema. After you see that, in fact, when you are using Elasticsearch, like Arish explained, Elasticsearch on the side also by default index process a JSON document and index different field to search or to sort or to store as a different field of the JSON document. And this is a schema that Elasticsearch will automatically create on the fly. So in this case, you will have different schema for different type.
Yeah, I mean, just to summarize, Elasticsearch needs schemas. SIREn doesn't, and the slide referred to Elasticsearch.
Okay, I think that clarifies. And there's another question: how can Elasticsearch SIREn be used to work with linked data? This is a question.
For linked data.
For linked data, so the thing is that originally, SIREn has been developed here for searching linked data. So it was originally the search engine of the Sinisha.com service. which was a research project that was aiming to index the web of data, so microformat, RDF, and so on the web, and provide search services for researchers and other people. And the thing is that, so these have been already used and originally has been used for linked data search. The thing is that we just kind of make it more generic for not only linked data but also for JSON document and other data model. After there is nowadays more and more the JSON LD syntax and the tool around the JSON LD, which make it even more simpler to index data into SIREn, because from a Sparkle query you can then transform it into a JSON LD, then using the framing technique to create not a flat JSON object but a hierarchical nested JSON object, and push this into SIREn, which is in fact this kind of pipeline is quite powerful.
Hope you enjoyed staying with us. If you need more detailed information, visit us at www.lod2.eu and let us know how we can improve to meet your expectations. Don't forget to register for our next webinar. Have a great day and don't forget.